It's a trifecta. If they're able to achieve all
Mhm.
three of those things at Battery Day, they've solved some serious engineering challenges because it's basically a first principles
Right.
problem. In order to solve a first principles problem, you have to have some really creative engineering.
Kevin in Colorado, aka your Tesla pilot, and we are talking about
Tesla!
That's right. We're about 5.5 days away from Battery Day. Very exciting. On today, Tesla stock price was between about 444 and 450 a share most of the day. We had that new launch from Snowflake that came out and sucked all the way up to about $160 a share. It sucked a lot of energy out of the tech stocks. We're a little bit of a victim of that today. But all hope is not lost. We still have tomorrow being Thursday and Friday to get us closer to that $500 benchmark before I still believe that on Monday next week we'll hit that between $550 and $600 a share prior to Battery Day. Today's exciting video, we're going to talk about some of the limiting factor guys talking about their predictions for Battery Day, and they seem to be pretty spot on. If you didn't catch the news day late in the afternoon, we got a hint or a glimpse of a possible leak of what the new Tesla battery will look like, and that's what you're seeing there on the teaser page of this video. It appears to be about, 4 times bigger than the average Tesla cell. So these guys are making predictions and talking about what they think Tesla's coming up with before they ever even saw this picture. The limiting factor.
There was also the electrode thickness. In the original Battery Day series, I said that they could increase the cell energy density by increasing the thickness of the cathode and anode. For people who didn't watch that video series, the reason why increasing the thickness of the cathode and anode would make for a higher energy density cell is because it reduces the ratio of active material to inactive material. Generally, I think an electrode foil is about 10 microns thick, and I don't know, for anode and cathode, it's something like 40 to 80 microns thick. So the electrode foil is actually pretty thick in comparison to the active material.
Yeah.
If you can increase that ratio, you have more active material, you get higher energy density. So
The reason why they generally don't increase the thickness is because of temperature concerns, right?
yes, that's a really
Was
good point.
that because if you have the end cooling, and then you have the tabless electrode, and then you also have the DBE process, all three of those play together into reducing the resistance of the system.
Yeah, so if you have a
So
thanks for drawing that in, because it's this is an example. Assuming this is your cathode or your anode, and these are to the entry and exit points for your ions, and also on the other side it would be the electrons. The thicker that is, the harder it is to get all those cars in and out of. Assume this is like a parking lot. Assume that the cathode and anode are a parking lot. The thicker this area is in here, the larger the parking lot, the more bottlenecks you get on the entry and exit points of that parking lot. And the more traffic jams there are at those points, the more friction there is, the more heat that's generated. And so quickly your cell's going to overheat if you make that cathode and anode too thick. And that it also causes problems when you try to roll that material, because it's harder to roll a thicker material without you getting creases and kinks in it.
Now, when they're talking about the roll, they're talking about the battery like a jelly roll. They lay that out, put down the material. Now they went from that wet slurry of that wet battery electrode, now going to a dry battery electrode, more like a peanut butter substance or a spray substance on top of that. And they take that and they roll that battery up. So that's what we're talking about, that material being difficult to roll.
And I'll bring up the triangle, which you're mentioning. And this is what I was talking about, the limits. The faster you charge and discharge a battery, the more heat that's generated. So that causes a problem with heat and the thermal load. The cathode thickness, you make the cathode thicker, you're going to generate more heat. If you make the cell thicker, you're going to have more heat. And
heat is bad. When everything that we move, including my hand moving through the air, causing friction, is the exchange of heat. All weather on the entire planet is caused by the exchange of heat. In this case, we don't want a lot of heat from our batteries or we lose our energy. We want to keep that heat, which is a form of energy by itself, inside the battery. Critical point here.
The day that the tabless electrode patent came out, I made a video because I was super excited about this and I could immediately see the benefits of it. And what this allows us to do, it actually allows us to shrink the size of this triangle or expand, depending on how you think about this. But
Yeah.
It allows you to solve all the problems at once. The tabless electrode helps out a little bit with that, and then the plate cooling, a better cooling system would also help out with that. So they might be able to increase cell volume, which makes manufacturing easier, along with making a thicker cathode, which increases energy density, and at the same time get a higher charge and discharge rate. It's a trifecta. If they're able to achieve all three of those things at battery day, they've solved some serious engineering challenges, because it's basically a first principles problem. In order to solve a first principles problem, you have to have some really creative engineering.
All right, so stay with me here. We're going to go a little bit down into a rabbit hole, get a little geeky for you nerds, but it's going to pay off. Stay with it.
Like 2 to 4x speed increase, then I would think we would be getting the entire S and X range with plaid. Well, not plaid, the entire S and X range with the new type of battery pack. And then the plaid would have some sort of extra capacity or extra fast discharge rate. I don't know. They might still want to have that delineation, but it makes more sense to put all the vehicles on the same pack. It'd be kind of weird to have two completely different battery packs running off the same line. It makes sense when you have like a 60 and a 75 kilowatt hour pack, but when you're running two completely different technologies, I don't know if that's feasible. So maybe do the entire S range or the entire X range, but I would think you'd need to do S and the X at the same time, just to keep things simple and to remove the Osborne effect. And then after that, Cybertruck.
Okay, what is the Osborne effect? I had to look it up myself. Here's an article back with Clean Technica, back from February 25th, 2019, by Martin Vekutskan. Sounds German. But it says the coming car recession as bad as the Great Recession of 2008. And this is going to go into the Osborne effect. Stay with me for a minute. It's going to pay off. It says a perfect storm is brewing above the automotive industry. Three hardly grasped phenomena are working together. Just like a real storm, when the conditions align in the best, worst way, we get a devastating superstorm. These phenomena or events are the Osborne effect of delayed demand, the technology cost curve of battery prices and other technology, and the S-curve that describes market acceptance of new technologies. These phenomena are often observed and not very difficult to understand in theory, but our mind is not wired to comprehend the implications. I'm going to say that last part again. But our mind is not wired to comprehend the implications. Our mind visualizes simple linear development, direct cause and effect. Together, these three create chain reactions of exponential and logarithmic trends, and our mind is simply not able to understand the consequences. Each of these three can cause disruption of an industry, like the S-curve that hit the mobile phone industry when Apple launched its smartphone. All three working together, amplifying each other, is what is going to happen in a couple of years to the auto industry with the advance of electric cars. Because it is the biggest production industry in the world, it will also disrupt the world economy. That is the Osborne effect in a nutshell. And what kind of foresight did this person, Martin, have writing this back 2 years ago, February 2019? We're less than 6 months away from it being February of 2021 when this will actually take effect, if not sooner. The Osborne effect will have a greater demand on EV vehicles taking over as the ICE engines die off and the GMs and the Fords of the world all collectively say, oh shit.
So I've seen a couple comments on asking about the 12-volt battery system, because I did think he did mention that the 12-volt battery system, or Elon did mention that the 12-volt battery system in a tweet recently, that it has some issues. Mm-hmm. And I think because if you look at the way that like a Tesla's designed, mm-hmm. The 12-volt battery system is basically a buffer of all of its subcomponents, like all the screens, all the buttons and all that stuff runs through the 12-volt battery system. And there has to be like a step down from the main battery pack to the 12-volt system but because it's running all the screens and all the electronics inside the car, the 12-volt system actually gets, it's not actually a lithium-ion battery. It's from my understanding, it's like a lead acid battery, like a normal car battery. And so it actually ends up getting cycled way more than the rest of the battery pack. And because of that, it's one of the earliest things to fail in Teslas is like you tires and then just that main battery pack. And so what they were talking about I think Elon was talking about in the past that he would want to replace the battery pack, the 12-volt battery pack, with somehow connect it directly to the normal battery pack. What are your thoughts on? Do you think there's a way that they could work that out, or what would they replace the 12-voltage battery pack with? Although Battery Bulletin just commented that he thinks they're going to replace it with a super cap, because Maxwell did have those kind of things in their product listings.
Duh. That's a beautiful idea. I haven't even thought about that yet. I was against the idea of a hybrid cell to pack with supercapacitors and a battery, but boom, I just had a brain explosion. A supercapacitor instead of that 12-volt battery. That's perfect. That would be beautiful, because then you would never have that 12-volt battery go dead. You'd want the supercapacitor that the whole system runs through to have a longer cycle life than the rest of the battery pack. Supercapacitors to use for more storage than that, I think, would be too expensive. So I've been thinking the supercapacitor would be good for things like the air suspension, things that are like running minor systems that are constantly cycling. I don't know enough about electrical engineering, but that's a brilliant idea. To me, that does seem like the core technology of the car, and maybe that's what Elon's referring to. You strip out that 12-volt battery, that old lead acid, toxic, prone to failure lead acid battery, and replace it with like a super cap or wired in directly to the actual battery pack. That makes more sense than me. The best part is no part. I prefer it to be no supercapacitor, but a supercapacitor seems like it would be better than lead acid. There's a couple questions on Roadrunner. What's the meaning of Roadrunner? To me, the meaning of Roadrunner is the fact that these cells are just going to be meep. They're just going to be blazing fast. And everything else, all the other battery lines, you could consider those Wile E. Coyote. Will Roadrunner be the million-mile battery? First, we need to take a look at what the million-mile battery actually is. There's an Easter egg in my last video that only one person picked up on. I said, is Jeff Dahn's battery actually a 2.5 million-mile battery? The criteria that Tesla gave Jeff Dahn for the million-mile battery was a full charge and discharge cycle, 0 to 100%, at room temperature at a 1C discharge rate. So 1C discharge rate would be charge and discharge the battery within an hour. So basically charge and discharge the battery within an hour at 100%, and it should last 4,000 cycles. Well, take a look at this red line. At 4,800 cycles, it's still above 90%. End of life is considered 80% for a battery. If you project this line out, you're looking at 10,000 cycles. If you have a 250-mile battery pack, you're looking at 2.5 million miles. If you had a 500-mile battery pack, that would be, 500-mile battery pack would be 5 million miles. And this has other implications. You may be able to reduce the amount of costly materials in that battery and still get a long cycle life battery. For instance, you might be able to replace the synthetic anode with a natural anode, reduce the cost. And for a vehicle, that makes sense because you want these batteries to be as cheap as possible. And there's no sense in having a battery that lasts 5 million miles because the car is going to die well before that battery dies. However, they could use these more expensive materials like synthetic anode in their power storage solutions, which need 10, 20, 30,000 cycles.
Well, and then I think something to bring up real quick. One of the interesting things that you do see if you look on Tesla's job postings, half of the job postings describe their batteries as Tesla energy batteries. So that could mean one of two things. Either they're putting their battery manufacturing division underneath their energy division, which actually does have an implication in terms of, like Elon said, that their energy division is going to be bigger than their automotive division, right? So if they put that under that division, that actually plays into that a lot. Or that means a lot of it, like they have a separate battery system for basically Tesla, and like Tesla energy batteries, and designed them specifically. Both of those are possibilities.
which is the Tesla Semi, which I was 50-50 about whether it would use a dry battery technology or Panasonic's wet slurry technology. Obviously, the Roadrunner cells would allow the Semi to have a longer range, but I wouldn't want to base the ramp of a vehicle that has enormous cell needs on a developing technology. You want to put that in your cutting edge vehicles. The Tesla Semi, Elon also said in the earnings call directly after the Semi release, was that the technology they had at that point was good enough to provide the specs that they stated on the Tesla Semi unveiling. And since then, they've made a huge amount of improvements to both their efficiency and their batteries. Not a huge improvement on their batteries, but there has been some improvement on the batteries, just like a few percent is my understanding, and their efficiency has gotten better. They should be able to do better than the specs they gave at the Tesla Semi unveiling. Yeah, I think it would provide some confidence, but I think if Tesla builds enough confidence with the market, I don't know if they necessarily need to provide a huge warranty, because it'll be obvious that these vehicles are lasting 2, 3, 4 times as long as an internal combustion vehicle. So I was 6 1, half dozen the other on it. Question about Elon's comment about mind-blowing. Personally, I didn't put a lot of weight on Elon's comment about Battery Day being mind-blowing. The reason for that is Elon, he'll often deliver on something that's impossible, and he'll do it without any superlatives, without saying it's mind-blowing, amazing, things like that. And then there's other times where he'll use superlatives, and then we'll get something that people don't necessarily consider mind-blowing. Like, for instance, before the V3 supercharger came out, he was like, somebody asked him about the charge rate of another charging system, and he said, "What is that, a child's toy?" And he came out with something that was lower than that. So I don't know what he meant by mind-blowing. All I know is what I know is mind-blowing. And that's everything that I've researched, from million-mile battery to faster production speeds to higher power density or higher energy densities.
Well, thanks for watching. I appreciate your time. If you like it, please hit the like button, and don't forget to subscribe to your channel. And hey, I really want to start a discussion. If you have some comments talking about your predictions of what's going on with Battery Day, what do you expect from Elon Musk? What do you think is going to happen to the stock price? Do you think the stock's going to tank right after Battery Day, or do you think it's going to continue to go on as we see delivery numbers come out for Q3? Please put in your comments below. Let's talk about it.